title of this lab is called Salt and Ice. Students were asked to investigate the following question. Does ice melt faster in fresh water or salt water? Students were given the opportunity to design an experiment that would investigate this question. This demonstration is for any student who missed the lab or for any student who needs to see the lab again in some way to help them understand it better. We have two beakers. One has fresh water in it. It's about 200 milliliters of fresh water. The other has fresh water also, but I'm going to be adding a certain amount of salt, and we're going to make it salt water. All right, to this beaker, I'm going to add 3 spoonfuls of salt. I'm going to stir it up a bit so it all dissolves. I'm not going to add any salt to this beaker, but I'm going to stir it just a little bit, only because I stirred the other beaker. I just want to be consistent. All right, I have colored ice cubes. They're green. I'm going to add an ice cube to each beaker. And we're going to observe what happens. So as we're waiting, you might want to record a few observations as far as what you see going on. Think about what the variables are. What is the independent variable? In other words, what is the one thing that we intentionally changed between the two beakers? What is the dependent variable? What do we expect to see a change in as a result of the change we made in the independent variable? And then what are the controlled variables? In class, I asked students to at least try to come up with about 5 control variables. More if possible, but at least about 5. Observations. At least try to come up with about 6 good observations. Right now, what I'm noticing is that in the freshwater beaker, the dye from the ice, which is actually marking the water that's melting away from the ice, is actually traveling toward the bottom and spreading out a bit. Whereas over here in this beaker, the dye from the ice, which is also marking the water that's melting from the ice, it's actually kind of staying up top. You can kind of see a layer forming there. Why do you think that's happening? We'll leave them for about another minute or so. Let's go back to the variables. If you said that the independent variable was the type of water, whether it was salt water or fresh water, or maybe you might have written down the amount of salt between the two beakers, you would be correct. The type of water or the amount of salt added to the water, that would be the independent variable, because that's what you intentionally changed between the two treatments or trials. What about the dependent variable? If you said that the size of the ice, or I'm sorry, not the size of the ice, but the speed with which the ice melts is the dependent variable, then you are correct. So the dependent variable is the speed with which the ice cube melts. And we'll take a look at that in a minute. And what about controlled variables? You were asked to come up with 5. Well, would 1 be the amount of water? We tried to keep the amount of water the same between both beakers. I think initially I mentioned there was about 200 milliliters of water in each beaker. What about the size of the ice? That would be a controlled variable because we wanted that to be the same between both beakers. What about the number of ice cubes? In each beaker, we only put 1 ice cube. So that's 3. Can you come up with 2 other controlled variables for a total of 5? Let's take a look at the size of the ice. From where I'm standing, I can see that the ice cube that's in the freshwater beaker is a lot smaller, is actually much smaller than the ice that's in the saltwater beaker. Again, the ice cube in the freshwater beaker is much, much smaller than the ice that's in the saltwater beaker. So obviously, the freshwater is causing the ice to melt much more quickly. Okay, why is that? Well, let's take a look. What you notice here in the salt water is that the ice is melting in such a way that it's forming a layer right on top. And that's indicated by the green color that you see coming from the ice. Very little of the color is actually throughout the body of the beaker. Most of it's right up top. Over here in the fresh water, you can see that the water from the ice has kind of spread all throughout the beaker, and that's indicated by the color. And you can actually see, some of the meltwater from the ice still kind of streaming down, and it's like it's going straight to the bottom. So density obviously plays a big role in this. Which is more dense, salt water or fresh water? If you said salt water, then you are correct. In this case, the salt water is on the bottom. It's more dense than the fresh water that's melting away from the ice. So there's a freshwater layer right up top. Over here, the density of the water melting from the ice and the water that was already in the beaker, the fresh water already in the beaker, aren't that different. So as the ice melts, the 2 waters mix pretty easily. Over here they don't. Now, with that being said, that still doesn't answer the question that I was asking earlier. Why is it that the ice in the freshwater beaker, why does it seem to melt more quickly than the ice that's in the saltwater beaker? Well, if this whole green layer up here is water that's melting or water that's melting right off of the ice, then we expect this layer right here to be much, much colder, so it's actually insulating the ice and preventing it from melting as fast. Whereas over here, the water that's melting from the ice is actually spreading throughout the body of the beaker, and it's mixing in with the rest of the fresh water, so it's not insulating the ice as well. But over here again, it's like a very, very nice layer of insulation right on top. The fresh water is less dense than the cold water, than the salt water, and so that cold fresh water insulates the ice in this beaker and preserves it. On your lab sheet, be sure to complete your conclusion. Think of a real-life application for this lab. Do you have any general questions? If you do, please write them down in the section that says General Questions. What questions would you propose, would you like to research in the future? related to this lab? Or what would you do differently? There's a section for you to write information about that. And we're done.